Okay, as we pick up here on equation solving, what we've done so far is we've tackled, x plus 10 equals 14, and we said we got to get rid of the plus 10. X equals 4. Okay, and then we've tackled 3x equals, 30, and we divided by 3, and we said x equals 10. Okay, we had more complicated variations of those two things, but that's basically what we did so far. Well, now we're going to put these two things together, okay? We're not going to have 1x, we're going to have, 3x, and we're going to have something plus or minus equals something else. So we're going to combine the two things of having something other than 1 for the coefficient and then plus or minus something, all right? It really doesn't matter which one of these two things we tackle first, the 3 or the 1, but 1 is usually a lot easier and less prone to mistakes. So and I'm not going to go through why. Usually I do it both ways, but let's just do it the easy way. We're going to take care of the 1 first. So I'm going to subtract that 1 from both sides. I'm going to get 3x equals 6, and then I'm going to divide by 3, and I'm going to get x equals 2. All right, so we'll tackle that plus or minus number first, then we'll divide by our coefficient. All right, that was pretty good. How about this one? Negative 2y minus 28 equals 4. We're going to tackle this minus 28 first by adding it to both sides. Negative 2y equals 32. Divide by that coefficient in front of y, which is a negative 2 in this case. Y equals negative 16. Okay. All right, we had one similar to this in the last video, but I only did it one way because it wasn't gonna, we didn't quite learn all the tricks to do it both ways. Well, now we can do it either way. I have x's and I have constants on both sides of the equal sign. I need to make a choice. Put the x's on the left and the constants on the right, or vice versa. You get the same answer either way. I'll only do it one way here for us tonight. I usually just put my x's on the left unless there's some good reason not to. So I'm going to make that minus 2x disappear by adding it to both sides. Well, now I'm going to combine these terms and give myself a 5x. Minus 14 equals 6. So now I want the minus 14 to go away, so I will add 14 to both sides. 5x equals 20. X equals 4. Okay, it's pretty straightforward, this equation solving. Okay, it really is. Let's do a few more. We'll just trick it up as we go. You'll see all these are just kind of tricked up as we go. We've got all the techniques we need. We really do. We're just going to take it up a notch or two. Look at this next one. Now I'm going to have some more simplifying to do first. Okay. 2x minus 8x plus 40 equals 13 minus 3x plus 3. On each side of this equal sign, I'm just going to combine like terms. Negative 6x plus 40 equals 10 minus 3x. Okay, I'm just combining like terms here. I'm not trying to undo, make things disappear. I'm not trying to do that yet. I'm just combining like terms. That's it. Now I want to make stuff disappear. I'm going to put my x's on the left and my constants on the right. So I want to make the x disappear over here. So I'm going to add 3x to both sides. So I'll get a negative 3x plus 10 equals 10. Subtract 10 from both sides. Ooh, look at this one. Negative 3x equals 10 minus 10, which is what? Did I make a mistake? Oh, that's a 40. That's a 40. I did make a mistake. Negative 3x, because it would come out to be 0. And there's nothing wrong with 0 for the answer, but I wasn't expecting it. So, okay, it's not 0. It's going to be negative 30. Divide by negative 3, divide by negative 3. We're going to get x equals 10. Okay. Remember the old distributive property? 5x equals 8 parentheses x plus 3. We got to do the old distributive property first here. 5x equals 8x plus 24. Okay, subtract 8x from both sides. I'm going to get a negative 3x equals 24. Divide by negative 3, divide by negative 3. X equals negative 8. All right, well, if we can distribute once, we can certainly distribute twice, wouldn't you think? And that stands to reason. 2 parentheses x minus 3 minus 17 equals 13 minus 3 parentheses x plus 2. All right, let's do it. I'm going to get 2x minus 6 when I distribute there. Then I had a minus 17 equals 13. Now, the danger with this is that you have to remember to distribute the negative right along with the 3. So it's minus 3x minus 6. Combine like terms on either side here. So I'm going to have 2x. I got the minus 6, and I've got the minus 17. That's going to give me a minus 23. And over here, I've got the 13 minus 6, positive 13 and minus 6. So that's 7 minus 3x. Constants on one side, variables on the other. So I will add 3x to both sides. That will give me 5x minus 23 equals 7. Add 23 to both sides. 5x equals 30. Woo! A lot of little steps here, right? Divide by 5, x equals 6. Okay. If we have fractions, you know, there's a way to clear fractions out of an equation. It's kind of nice. You can't do that if you're just adding two fractions, but if you have a fractional equation, there is a little technique to help you out a little bit. You see, I've got denominators of 2 and denominators of 5. My common denominator of everything would be 10, right? So if you identify that common denominator and you multiply through the equation, numerator only. So I'll put it 10, I'll call it 10 over 1. Multiply numerator only by what would be the common denominator. Well, let's see what that does for us. That gives me 30x over 2 equals 10x over 5 minus 390 over 5. That looks worse, right? Doesn't look like it helped at all. Well, it actually did, because that 30 divided by 2 is now a 15. So it's 15x equals that 10 divided by 5 is now a 2x. And that 39 divided by 5 is going to be a 78, minus 78. Okay, so now I have no more fractions. I'll subtract my 2x, and I will get 13x equals negative 78, and I will divide by 13 on both sides. I will get x equals negative 6. So you can clear a fraction right out of there by finding the common denominator, multiplying through the entire fraction, the entire equation, numerator only by that common denominator. Then all the fractions magically disappear. Okay, there's a similar technique where you can get rid of decimals, but especially with calculators, I don't find decimals to be all that difficult. I mean, we could run through it real quick just for laughs, I suppose. 0.3x minus 1.8 equals 0.37x minus 1.1. There's no big deal to just dealing with the decimals, right? You got to put the constants one side, variables the other. There's decimals, but big deal. Well, if you really, really don't want to deal with decimals, what you can do is ask yourself a question. What would it take to turn that decimal into a whole number? I need one decimal shift, one decimal shift, 2 decimal shifts, 1 decimal shift. I got to identify the largest number of shifts required, 2 shifts. That means 2 powers of 10. That means 100. So I can multiply the equation by 100, both sides. 100, 100. What did that do for me? It turned my 0.3x into a 30x minus 180. 1.8 turned into 180 equals 37x minus 110. The numbers got bigger, but guess what? My decimals are all gone. Now, maybe the answer will still be a decimal, but I don't have to deal with the decimals as I'm moving around here. Okay, so some people find that easier. Put my x's on one side. I've got negative 7x minus 180 equals negative 110. Add 180 to both sides. Negative 7x equals a positive 70. Divide by negative 7. I get x equals negative 10. Okay. All right, that's the basics of equation solving. Remember I said these linear equations, I said in the previous video, they have a unique solution except for two specialty cases. So let me just quickly throw those at you. I didn't see any evidence on the exam that you may ever have to cross this bridge, but real quick, just in case. If we had an equation, let me just get one that's gonna work here. If I had an equation like this, 2x plus 6 equals 2 parentheses x plus 4. Well, okay, let's simplify. 2x plus 6 equals distribute 2x plus 8. Right here, you should spot a problem because remember, an equation's a balance. I got 2x plus 6 on one side, and I got 2x plus 8 on the other side. How could these ever be balanced? Because the 2x and the 2x always balance each other out. No matter what x is, they're always balanced. But these two things are always out of balance. Okay, so if I try to solve it, put the x's on one side, all of a sudden the x's completely disappear, and I'm left with the statement that 6 equals 8. Okay, and that's a false statement, of course. So that means there is no solution to this problem. Okay, nothing. No answer, not 0. 0 is a great solution to some problem, not to this problem. What would happen if I put a 0 in here? If I put a 0 in here, I would have 6 on one side of the equal sign, and I would have 8 on the other side of the equal sign, right? That's not going to work. So 0 is no good. There's no solution at all. Nothing will work, okay? One extreme case. The other extreme case, if I had something like, if I had something like this, negative 3x plus 5 plus 5x. See, there's no indication it's going to be trouble right now because it's kind of messy, but once we simplify it out here, combine my like terms, negative 3x and a positive 5x will give me 2x plus 5 equals, and over here, look, I also have a 2x plus 5. They're identical. No matter what value of x I could ever dream up and stick in there, it's always going to work, right? Always. But if I go through the motions, I solve for x, I put all my x's on one side. Again, the x's disappear, but this time I'm left with a true statement. Okay, so that means there's an infinite number of solutions. Okay, or we say all real numbers. Any number I can dream of whatsoever works in this equation. No number I can dream of whatsoever works in that equation. All these other ones, exactly one number and only one number work in these linear equations of one variable. Okay, other types of equations have more than one solution, but not this, not these. Okay, all right, so there's a little, between this video and the last, it's a nice little introduction to solving linear equations. In the next video, we'll look at some more fun stuff. Thank you.